All right. Welcome back, everybody. Thanks for coming out to Hello World, Class 2. It's pretty good class size today. I guess the weather's worse, isn't it, than last week? Okay. So we're going to start off by reviewing just a few things. I've had a lot of questions about Piazza, where's the homework, kind of timing of office hours, and lots of other stuff. So just kind of want to go through all that stuff one last time to make sure that we all understand what's going on and how to best utilize the resources for this class and give you a chance to answer questions or ask questions. So getting into Piazza. So you all should have received an email for this. If you're not, has anybody not been able to log into Piazza yet? Is there anybody? Okay, cool. So when you're in Piazza, the main ways to interact with it are through this Q&A. And so you can filter by any of these kind of folders up at the top left. Those are based on topics. So when you create a question, you select which folder it will go into. You can select that it goes into multiple folders. So if you're working on stuff for class 2 or you're a little behind, and you're still kind of working on one of those problems for class 1, you can go see if anybody's already asked that question. And so that will filter those questions, and you can clear the filters just by clicking those little arrows there. And so generally this is going to, you're getting email notifications for these. You can change your settings. If you don't want to get email notifications for class questions, you can go turn those off in your account settings. And so otherwise, you'll just get email notifications when anybody in the class posts a new question. The resources tab is also going to have some other good, useful stuff. So you can bookmark one or both of the class website or Piazza, and that'll allow you to get to the other one. So just make sure you have one of those bookmarked. If you're in Piazza, on the resources page, you can find the course website just under the resources general information section right there. The class email. Again, if you have general questions, please post those to Piazza because those might be useful to other people. If you have specific questions specific to you, you can send them to the course email, and myself or Crystal are the ones that are going to be answering those. Obviously, you know when class time is because you're here. The meetups, or office hours as we're calling them, are going to start on Monday, this Monday, and they're going to be here in the space from 5:30 to 7:30 p.m. And those are just going to run every Monday through the class. And we'll continue those after the class too in a sort of different structure. While the class is going on, that's just a chance. These are optional. That's just a chance for you to come in, work with some of your classmates, get some help from mentors. We do have a few mentors here today. So aside from me, there'll be a few other folks around that'll be able to answer your questions and help you out with your work. Just another kind of time to give you an opportunity to get some help as you're learning this new material. And then there's finally Code Academy. Our Code Academy is a link there. We're going to use that starting today. I'll say more about that at the end of class. Okay, any questions about Piazza? Cool, let's go to the course website. Where is it? I closed it. Well, okay. So the course website, everything useful pretty much is under the calendar. So where's your homework? It's on the calendar. Where's the lecture notes and the slides from last class? It's on the calendar. Where is the prep material for next class? It's on the calendar. That's generally the answer to where is blank. All right, so it's pretty laid out here pretty clearly. Again, just the format. Prep work before class is stuff that we would like you to do before you show up for that class. So here the prep work was class 2 prep. Hopefully you did at least some of this before coming in today. That's there for you. Then in class will be any materials related to the class itself. So this is where I'm going to post the slides, the video and the audio, any kind of supplementary links, any kind of notes, things like that. And then homework will be where we post the homework for each class. So the order of these would be to say, do your homework from class 2. Once you get that done, try to do some of the prep work for class 3, then come into class 3, okay? There really wasn't homework for class 1. There is homework for class 2, which is already up. And so we'll talk about what this homework looks like at the end of class. Any questions about where things are? Okay, cool. All right, so I mentioned office hours, Monday, 5:30 to 7:30. Those are optional, of course. And then also Mentor Center availability. I did mention that this space is open during the week and available for you to use. And it's our website. You can find some information about that on the Mentor Center page. I just typed it in because I know it, but the link is always at the bottom of every page, Mentor Center. At the top here, you have Hours 9 to 6 Monday through Friday. So that's when we are always definitely open. Now, like there's people here in the evenings for other classes and stuff like that. But if you want to come in and know there's going to be a space for you to use the space, that's what you can do. If you want to come in and get help from a mentor, the mentor schedule is here. And so currently we have about 2 mentors coming in at different shifts. That'll kind of increase over the time that we're open and build up more mentors. But if you know you want to come in and get some questions answered from somebody, that's going to be your best bet. While I do work here and while I am here during the day, I generally can't answer your questions during the day because my mentor center job is separate from this teaching job, and I have different categories of work. So if it's simple questions, I can help you out with stuff, but I'm not going to be able to sit down with you for 30 minutes or an hour to actually help you get through your work during the week. So, but once again, mentors on Monday night will always be there as well. Okay, enough of that. So let's just review a little bit about what we talked about last week. So last week we talked about what is this thing called code that you hear about? What are programs? Code is stuff that looks like this. There are a lot of programming languages, different languages. We saw examples of them last week. Code is it's a series of statements in a given language that does something. It looks like this. It runs on our computer, and then there's some result that happens at the end. So this is just a little snippet of code that asks somebody to type in their name and then pops up a window and says, hello, you. Hello, Chris, if that's what I typed in as my name. So it's a set of instructions that we give to a computer in a programming language that can then run on that computer and carry out some action. And we, as the programmers, are going to be the ones determining what those actions are, determining what we're instructing the computer to do. So that's what code is. Just kind of a brief aside on that. We talked about things like machine code and compiling and binary. Does the computer by itself understand this? No. What's the difference between this and what a processor understands? Do you remember one of the videos had illustrated it really nicely? A computer needs some way to turn this into basically binary instructions. A processor can really only do a few basic things. It can take sequences of zeros and ones and add, multiply, divide, things like that. It can't understand words like this. So there's a process in the middle there, typically called compiling or interpreting, that will turn this language, this computer language, programming language, in this case this is JavaScript, or it can be another language, it'll turn it into something that the computer can then understand. So that's just an aside. You'll hear that more and more as you learn more and more about code. We also talked about algorithms. So an algorithm is just a self-contained, step-by-step set of operations to be performed to solve a problem, carry out a set of actions, etc. It's a sort of a recipe. It's just a sequence of things that should be done to get some end result, okay? We also talked about what a computer program is. What's the difference between, say, a computer program and an algorithm? Which one's potentially bigger? A program, right? A program can have lots of different algorithms. A program can have just one algorithm and also might have 5,000. Facebook is a computer program. It does millions and millions of very different things. It has lots of different algorithms contained within it. An algorithm is just like an atomic unit, a small thing, a specific set of actions for a specific purpose. And we talked about writing algorithms in pseudocode. So pseudocode it's kind of a mixture of English and actual code. It's not formalized the same way that programming languages are, but it does use some of the same frameworks and paradigms and patterns that we use when we talk about programming languages. So it's somewhere in between English words, like you would see in a cooking recipe, and actual code. And the usefulness of this is that it lets us talk about and think about things and write algorithms in a way that's a little bit less formal than actually coding them in a programming language. So definition here, instructions written out one after the other, like code, employing basic constructs like repetition and decision making. And we call those two looping and conditionals. We'll talk more about those today. So that's a review of what we covered last week. Today, here's what we're going to do. We're going to kind of go into pseudocode in a bit more detail and do some more examples. We're going to do a lot of practicing and kind of get really good at trying to break down problems and solve them and write pseudocode and write algorithms for problems. At this stage of your exposure to programming, kind of just repeating these things and getting your brain into the habit and the pattern of thinking critically and thinking in these structured ways, thinking about how to use loops, thinking about how to use conditionals is going to be really critical. So it's a lot of just repetition and practice and getting good at these things. The first time you write a loop is not going to be the time that you understand it totally. It's going to take a few times. So we're going to do a lot of practice, and then we're going to introduce JavaScript a little bit, I hope. We're going to see, I don't know how the timing on this is going to work out. Hopefully we get to JavaScript a little bit and can get you kickstarted on that, because some of your homework involves a little bit of JavaScript over the next week or so. Okay. So we're going back to pseudocode. We talked a little bit last week. We introduced it, and we did like a group exercise. We saw a few examples. Your prep work introduced you to pseudocode some more. What is pseudocode used for? Is this, I mean, at this stage, you might think this is just something we're doing because we don't know how to code yet. And then once we learn how to code, we're done with pseudocode, never to use it again. But actually the opposite is the case. You will use pseudocode for your entire life as a programmer. And it's really, really useful, and for the following reasons. One is that it lets you sketch out solutions more quickly. So you can start thinking about a problem and start thinking about how to solve a problem and break it down without having to get tied up into the minutia of the actual programming language. Okay, so it allows you to focus on concepts rather than details. We'll see at the end of class when we start talking about JavaScript, the programming languages are very, very rigid. They have a lot of rules, and if you don't follow those rules explicitly, you're going to have problems. And so once you start actually coding in a language, you're also dealing with the mechanics, the rigid mechanics of that language. Sometimes those can get in the way of thinking about how to solve the problem. Sometimes you might write a program and it has an error in it. The error is really with your logic rather than, say, your syntax. And we'll talk about what syntax means a little bit more later. But pseudocode is just a nice way to kind of think about these things and sort of outline how you might solve a problem in code without getting tied up in those details. It's also language agnostic, and agnostic just means that pseudocode is not a language. You can solve a problem in pseudocode and then go write it in any language you want for the most part. It doesn't care. You can say write an algorithm in pseudocode and then go do it in JavaScript or Python or Java. So you don't have to worry about that detail. You can be working with somebody who might not know the same language that you're most familiar with and still kind of speak the same problem-solving language. Okay, so we're going to run through the basic pieces of pseudocode, and these are also, as I mentioned, also the basic core building blocks of all modern programming languages. So I think this is a little bit different order than we did last week. Some of this is going to look similar. I've used some of the same slides, but we're going to go in a little bit more depth and do some more examples. So a variable. Variable, I said, is something you should think of as a bucket. It's going to be a bucket that stores information. A variable is something that has a name that stores a value. That can be a number, a letter, a word, any of those things. It can be objects. An object is something that's much more complex that you'll learn about later in your coding adventures. So the reason we do that is that, one, we can update it later. We can kind of keep a value. We can hold on to it, keep it in our little bucket, and then later come back and refer to it. Two, often we're not going to know specific values of things when we're writing our code. So in that example I showed earlier, that little pop-up where you type in your name and then you get a little message that says, hello, Chris, hello, Brian, hello, Julie, whatever the user types in their name, the code doesn't know the name that's being typed in, right? So I have to use something generic. A variable is a generic way that I can refer to something that I don't know the value of right at this moment. Okay, so just a couple of variables, same ones from last week. One of the things we didn't talk last week about in regard to variables are what's called data types. So we're going to dig into that a little bit now. So I can create several variables, and let me over to my text editor. Big enough? Okay, so I can create a variable, and let's see, I had number of. One thing when you do variables, notice that I just did that. I just did a mistake and I undid it. I did that. I'm not allowed to have variables with spaces in them. Generally, there are generally going to be rules about what kinds of things can and can't go in variables. But a variable should just be one string of characters. You can use other things like dashes and so forth, but never have spaces. LaunchCode. Another variable. Is weekday? False, because today's Saturday. So here are 3 different variables that have 3 different data types. Okay, so this one is a number. In fact, it's actually a specific type of number called an integer. Integer just means a whole number. It's not 2.5, it's just 2. This one is what we call the string of characters. This one is what we'll call a Boolean. So these are the 3 sort of high-level data types that we'll focus on for most of this class. And the reason why we talk about data types with respect to variables is because they're different types of things. Once we start using variables, we'll want to start doing things to them, right? We'll want to start adding numbers together. We'll want to start increasing the number of burritos I ate today when I go to Qdoba. We'll start, make the full address of LaunchCode and add onto that string. And so these operations will only make sense with things that are the same type. Can I take an address and add it to a number? Does that make sense? What does that mean? 2 plus 4811 Delmar? That's gibberish, right? Can I say false minus 2? What does that mean? That doesn't mean anything, right? So there are these basic operations that we'll be applying to these variables, and so we'll care about what data type is actually stored in the variable. We'll care about what information is in there. All right, so when we're dealing with pseudocode in JavaScript, generally you just kind of have to remember what data type you put into a variable. All right. Later on, when you deal with more complex programming languages, you'll be forced to say when you create the variable, hey, this is an integer variable, or hey, this is a string variable. So, for example, I can't do things like LaunchCode address plus number of burritos. Actually, in JavaScript, the computer will kind of let you do this, but what happens at the end is anybody's best guess, right? It doesn't make sense. So we shouldn't try to do it. Another nonsense statement would be to say number of burritos divided by is weekday. Or I divide 2 by false. I don't know. So pay attention to what you're putting in and start thinking in terms of data types. Is this a string? Is this a number? Is this a Boolean? One more remark about strings is that for our purposes and for JavaScript's purposes as well, this is going to be the same thing as using single quotes. However, I can't do the following. Okay. So the top 2 are both cool. I can say LaunchCode address equals double quote 4811 Delmar, close double quote. I can say LaunchCode address equals single quote 4811 Delmar, close single quote. I cannot leave off the quotes. Okay. The reason for that is that when we're looking at programming languages, we said that, and we'll see how this plays out in practice, programming languages are very, very rigid, and they have rules. One of the rules is that a string always has to be in quotes. If it's not in quotes, the computer doesn't know where the string starts and where it ends, okay? It also doesn't know what's to say that this is a variable and not a string, right? My variables don't have quotes around them. So adding quotes around something distinguishes a variable from a string because they're both kind of words in a way, right? If Delmar happened to be a variable, I could do that, right? I could say 4811 plus Delmar, and that would make sense, but that would be a very different thing than the actual string. So this doesn't make sense. So even when you're pseudocoding, start thinking about data types, start thinking about using these practices. Definitely use quotes properly, and pay attention to what you're putting where and what you're trying to add, multiply, things like that. Okay. One more piece that I'll introduce here. Operations. So math operations are all kind of exactly what you think. You can take 2 variables, add them. This is valid. The thing you're going to do with variables is take different variables and apply operations to them. Again, if the number of tacos isn't a number, that's not going to make sense. But if it is, I can add one number to another number, right? Variable on the left is a number, variable on the right is a number. That's totally cool. So when it comes to numbers, all of the basic operations that you want to use are there. So you can plus, minus, divide. You can use modulo, which does modular arithmetic. If you get to one of the challenge problems in the homework, you'll see kind of how that might work. So all the kind of basic math stuff you expect to be able to do with variables, you can. With strings, you can add strings. You can say, this. Okay, so I've got this new variable I'm creating called LaunchCode mailing address. It's going to be equal to LaunchCode address, which is a string. You can just think of this value substituted in for this variable. And here, plus with strings, plus means join them together, put them end to end, okay? Concatenate, if you will. So I'm going to add this new little string that just has a space and a comma. And then after that, I'm going to put the city. And actually, I probably want to put comma space. So what will this result of that manipulation be? What will LaunchCode mailing address be if I say it's LaunchCode address concatenated with comma space concatenated with LaunchCode city? And I'm going to put quotes around that to signify that that's a string. Cool. Does everybody follow that? Good. All right. So that's one of the operations you can do with strings. There are other operations you can do with strings, but that's going to be the basic one. Finally, the most basic operation you can do with a Boolean is to use what we call the bang operator. It's just an exclamation point. You could think of this as negation or the word not. Anytime you see like a single exclamation point in code like this, think not. That's what it means. So it's not whatever's in front of it. So if is weekday is a Boolean, it's equal to false. Not is weekday is the same as not false, which is what? What's the opposite of false? True. Okay. Weekday and weekends are opposites. So if is weekday is false, then is weekend is going to be true. So you can change the value of a variable, or you can negate the value of a variable, I should say, by putting the bang operator in front of it. Those are the basic operations. And we'll come back to these again and again and again, and you'll get these kind of drilled into your skull through practice. Any questions on variables and data types so far? Yes. It's a convention. So in different programming languages kind of had different conventions around how you should name things, and programmers generally kind of adopt these to kind of have just a nice way to like keep code clean and readable. Generally, you'll find that variables almost never start with a capital letter. Almost never. There's very few conventions that do that. That said, if I'm like writing JavaScript, JavaScript doesn't care. You can capitalize everything if you want. You can capitalize every other letter if you want. It doesn't matter. At the end of the day, it's just going to take that word and turn it into like something else that it understands. So this is just again, it's a programming convention. It's something that once you start coding, you'll fall into these patterns because the code you read will follow these patterns and because other people will do them that way too. Also notice that what I'm doing is called, it's not quite camel case, but basically each new word gets a capital letter, but the first letter is lowercase, right? So that's a convention too. You see this in Java in particular. JavaScript, it's one of the main conventions. Another thing that people will do is to use like underscores instead of capitalization. So not a huge difference. The main thing is like try to be consistent with what you do. That way, at least you will be able to read it a little bit better. Another question back here. Again, another convention. That's just that is just signifies generally that this variable is a Boolean. Is a state. Is something true or false? Okay, so if I call a variable by a certain name, that can carry, like by giving it that name, that's kind of me as the programmer saying, whatever I put in this, it better be a Boolean. Does that make sense? If I just called it weekday, maybe that would be like the number of the week, like 2 would be Tuesday or something. You know, it's not obvious what that variable's holding. If I say is weekday, again, this is just a convention. It's not something that the programming language is going to like make you do, but this is just going to make it easier for me to remember that, oh, that's probably a Boolean because I put is in front of it. In front of variables that are Booleans. So if you make a new variable that's a Boolean, one convention is to put is as the first word in that variable. Again, you don't have to. It just kind of helps me later on when I'm reading it understand what I wrote. Yes. 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 Any other questions about variables, data types? Yeah. Great question. So what do we think here? Let's see if the class has a hive mind answer. What if I did this? We think that one way, should these be the same? Should they not be the same? We should be able to use the word false in a string, right? That should be something we're able to do. So by putting quotes around it, I'm treating that as a string, which is just a set of characters. By not putting quotes around it, it's a Boolean. So the point that you might be thinking of is that how do I know that that's actually a Boolean? Because it's just a word. There's nothing around it, right? Well, it turns out that the word false in pretty much every programming language is what's called a reserved word. It means you don't get to use that word. I can't make a variable called false. I can't say false equals 5. I can't do that because that word is special. It's reserved. And every programming language has reserved words. Anybody guess at another reserved word, a word that you're not allowed to use? True. Something else that we saw maybe like earlier in the lecture last week, another word. If, yeah, you can't use if, you can't use for, you can't use while, else. These are all reserved words. If you try to make a variable called if, you're going to get yelled at. So, so yeah, that's a really good question. Others. Okay, so yeah, // This is something, where was I going to get to it? It's probably a little bit later. So I'm putting these forward slashes all over the place, and I probably should have introduced this idea first. All that means is it's a comment. It means that this is a little note to myself that isn't code that the computer should just ignore. It's just a little note. It's just me keeping track, me annotating my code, me like writing things that will help me understand what I did later. It depends on the language you're in. So we're going to do JavaScript, and JavaScript uses double slashes. A lot of other languages use double slashes as well. So that's kind of why I'm doing pseudocode. I'm just going to do that too. That just says, hey, this is not code. This is just a little note. So back to your other point, is weekend equals not is weekday. So exclamation point, I said, think about that as not. So I'm going to create a new variable called isWeekend, and I'm going to set it equal to, a variable's a bucket. What am I going to put in that bucket? I'm going to put in whatever's on the right-hand side of that equals sign. The right-hand side of that equals sign is not is weekday. So that's kind of a formula I have to unwind, right? Is weekday is false. So by saying not false, I'm actually getting true. So I have this new bucket. What I put inside of it is the value true. Does that make sense? Make more sense? You can, but what if I didn't know what today was in my code? Right? What if it was a Wednesday and my code was just running away? Is it a weekday? Is it a weekend? So yeah, in this case, for this sort of simplified example, but in general, you're going to use variables when you don't know the actual value of something. So these are all kind of simplified examples, but you'll see this play out in practice pretty quickly. How we doing? Okay. We already did this. Conditionals. All right. So we talked about conditionals last time. And these are what we'll call if statements or if else statements. And conditionals kind of have this form. And so this is all just still pseudocode, right? This is the same slide we saw last time. Conditionals let us do something only if something else is true. So here, my code is going to learn, whatever that means, only if the student's at LaunchCode. The student's going to learn only if they're at LaunchCode. If the student isn't at LaunchCode, no learning. So that means that if my code's running, it gets to that if statement, and the student happens to be at, say, Schlafly at happy hour, they're not going to be learning. It's going to skip that line in the middle. So if something that's true or false happens to be true, then do it. If it's false, skip that line. It allows us to make decisions based on the truth value of an expression. Let's see what's... We do a quick example with that. So this is just again in pseudocode. If today is Saturday, print weekend. I'd also follow that up with if today is Sunday, print weekend. If today is Monday, print weekday. I could write code like this that would just print weekend or weekday based on whatever today was, right? And again, this is pseudocode. This won't make sense in JavaScript when we get there. So I'm not going to get the word weekend printed if it happens to be Monday or Tuesday or Wednesday or any day but Saturday or Sunday, right? Another way to look at conditionals, or another thing you can, another more complex way of creating conditionals that allows you to kind of be a little bit more efficient. And this allows us to do things using if and else. Else is something we didn't talk about last time. So I said that I can write, say, if condition, do something. And if the condition's true, that something will happen. But now I'm introducing another piece, which is to say, I can also add after that else if and else. So what this will do is allow me to, rather than just like asking a bunch of questions, it'll allow me to do something if something's not true. So rather than just doing an action when something is true, rather than just printing out a word when, say, Saturday is true, I can also do something if it's not true. So let's rewrite this using if and else if, and we'll kind of see how this works a little bit better. You can say if today is Saturday, weekend, else if today is Sunday, print weekend, else what? If today's not Saturday and today's not Sunday, print weekday. Okay, so notice this is more efficient because this will cover all of the weekdays, right? This statement gets hit if it's not Saturday and it's not Sunday, then it's one of the weekdays. I don't care which one. And so I'm just going to print weekday. Up here, if I was just going to use ifs, I would have to add 4 more if statements here, right? To get those all to print out. I'd have to add one for Tuesday and Wednesday and Thursday and Friday. This is just far more efficient. It lets me kind of do things when something's false. So if today's Saturday, I can print something, print the weekend. Else if today is Sunday, print weekend. Else print weekday. Any questions about what's happening with that example? So if else, you'll pair those a lot. Else if you won't use as much because that's a little bit more complicated. That's like if there's like multiple decisions that could be made. Usually you're going to be asking questions that are like yes or no. And so you'll most often just have if and an else. So let's do one more example of an if else. odd, even. So if x So here is something new for us. I put an if statement and I said if x modulo 2 is 0. So x is a number. Modulo means take the remainder after dividing. Okay, so if I say take 3 modulo 2, the remainder dividing 3 by 2 is 1. So 3 modulo 2 is 1. Make sense? 5 modulo 2 is 1. 4 modulo 2 is 0 because 2 goes into 4 evenly. So modulo just says divide by this number and then take whatever's left. So that's what modulo means. So in particular, I can use modulo 2 to say whether a number is odd or even. X modulo 2, if that's 0, that means I have an even number. It cleanly divides by 2. That's the definition of even. If it's not divisible by 2, what else? What do I have? Here. It's odd. Okay. Any questions on that one? Yeah. Sure, I'll run through one more time, then I'll get to your question if it's still unanswered. So doing modular arithmetic, saying x modulo something means divide by this number and then take the remainder. All right, so let's just do like a quick math. Listen here. 10 modulo 3. What is that? What is that? 10 modulo 3. I divide 10 by 3, which 3 goes into 10 3 times. There's 1 left over, so that's 1. 7 modulo 5. We're good with modulo? Saying x modulo 2, that says whatever value x is a variable. It can have any value. Dividing by 2, I'll either get 1 or 0, depending on whether or not x is even or odd. If 2 divides evenly into x, I'll get 0. 2, 4, 6, 8, 10, 12, whatever. Dividing any of those numbers by 2 with modular division will give me 0. If I have any odd number, dividing that modularly by 2 will give me 1 back. So any odd number, modulo 2 is 1. Any even number, modulo 2 is 0. So this if statement just says, if x modulo 2 is 0, print x is even. Otherwise, we know that x modulo 2 is 1. It has to be. So we're going to print x is odd. Your question still? Uh-huh. You can, yeah. So I don't want to introduce ands and ors at this point yet, but yeah, you can do that. Yes. Modulo. M-U-D-U-L-O? Oh, M-O-D-U-L-O? I don't know. M-O-D-U-L-O. I spell it in the homework somewhere. There was a question here. In pseudocode, not really. I mean, you just start using variables. We'll get there. We'll talk about JavaScript and defining variables. Is there another? We good? Okay. So conditionals, this is a more complex, more robust, more useful form of conditionals using ifs along with else ifs and elses. Like I said, most of the time when you do this, you're going to say just have an if and an else. But you can also have else ifs. You can also have like multiple else ifs. You can say if something, else if something else, else if something else, else if something else, else. You can have 50 else ifs if you want to. Just really something very, very complicated. Most of the time, though, you're just going to have an if condition, else do something else. Okay. Okay, so loops. We talked about loops. This is, again, pretty much the same slide from last time as well. 2 types of loops. A for loop, which will let us repeat an operation a specific number of times. So the top loop says for 1 through 10, print hash. That's going to run that loop 10 times, print a hash sign each time. Print 10 hashes is what you end up with. The bottom loop is going to essentially do the same thing, but it's just doing it using a while. So the way that a while loop works is we have while something is true, do this operation. Then go back. Is that thing still true? Okay, do the operation again. Is that thing still true? No? Okay, end the loop. So this, I cut out the second slide. The general form of a while loop is while condition do something. Okay. And I'm kind of putting end whiles and end loops and stuff like that here and there. This in pseudocode, you can put them or not put them. Generally, if you're clean and indenting things properly, then you don't need to put them. So if I'm lazy about that and it's unclear what I mean, just call me out on it. But a while loop, that's what all the while loops look like. Whatever you put inside will only happen if that condition is true, and it'll keep looping around and around and around. The consequence of that is that if you, let's just take this loop that we just did, that we just saw. So I said while, I said I equals 0, while I less than 10, and hash. I equals I plus 1. That's the loop that we just saw as our example. So this will, the first time around, I will be equal to 0. I will be less than 10, so it'll print a hash. Then it'll add 1 more to I, so then I will be equal to 1. It goes back up to the top. It says, is I still less than 10? Well, I is equal to 1. So yes, prints another hash, et cetera, et cetera, et cetera. Eventually, I gets all the way up to 10, and it says, is 10 less than 10? 10's not less than 10. So then it stops at that point. What happens, though, if I forget to do this part? It'll just keep going. It'll just keep looping around and around and around and around and around, because every time I will be equal to 0, and every time 0 is still less than 10. So when you have a while loop, while loops are sometimes easier to think about when we're learning to code, because we can think in like these true-false kind of ways. We can say, I want to loop as long as this certain thing is happening, or this certain thing is true. But if my loop doesn't ever actually potentially change that condition that I'm evaluating, then it's just going to loop forever. Okay, this is what's called an infinite loop. Okay. We're going to do lots of examples of loops and conditionals and so forth in actual pseudocode later on today. So comments, here's what we talked about earlier, which I should have put this slide earlier in the lecture. Comments, we can add comments to our code or our pseudocode by preceding them with // So as someone over here mentioned, different languages kind of have different conventions. Most of the stuff, most languages have a // as the thing that you put in front of comments. Some might use a hash sign or something else. In pseudocode, though, let's just all agree to use // and that means that, hey, the thing after this is not actual code. Don't do anything with it. Just treat it like a comment. So this one, I have another while loop example. And so if I just didn't have that comment there, it might take me a minute to kind of like look at that and figure out what it's actually doing. So if I'm writing code like this and I want to just have a quick way for me to quickly remember what that chunk of code is doing later when I come back to look at it, I can add a comment and just say, hey, here's what this is doing. So that later on, it makes it easier for myself to read my own code or for somebody else to come in and see what my code's doing. Comments are good ways to kind of describe what you're doing without having someone to have to like actually dissect the operations that are all there. Okay, any questions so far? All right, so we're going to do some pseudocode practice and going a little slower than I wanted to. So we'll do a few examples together, and then we'll break apart, and you can work on your own or with pair up with folks doing some pseudocode examples. But together we'll just kind of get started this way. So by the way, all this stuff and all these little notes, I'm going to put all these scratch notes I'll post on the course website too. So I'm going to write a pseudocode loop that prints integers from 1 to 100, and I'm going to do this in 2 different ways. So first, let's do it with a for loop similar to the one we just kind of did. right? So first thing I want to do is create a variable to keep track of how many times my loop has gone around. If I'm going to go around 100 times, I want to be able to keep track of that. Let me actually use I'm going to start using more descriptive variable names. So I'm going to check a condition each time I go around. I need to decide if I still want to print that number. I'm going to print the number if it's less than 100, right? Actually, start at 1, shouldn't I? Start out at 1. I want to print the number as long as it's less than 100. I could do less than or equal to. I could do it this way too. Less than or equal to 100. They're both kind of equivalent. And it prints number to print. Okay. Now what do I need to do before I go back and start my loop again? I need to add 1. Increments my variable. So we're going to start out, our number to print variable is going to start out at 1. Each time we enter the loop, we're going to print that out, and then we're going to increment it so we can print out the next one the next time around. Once I actually get up to, say, 101, this condition will no longer be true. I'll have 101 less than or equal to 100 as my test. That test will fail, and then I'll end the loop and keep going throughout the rest of my program. Okay? The other way we can do this is with a for loop. We can say for number to print equals 1 ... 100 prints number to print. So there's another, so what's kind of like different about these two? What am I doing in the while loop that I don't have to do in the for loop? I'm still, it's implicit. It's kind of, the end condition is the 1 ... up to 100 kind of. But what else is not, how do I ever get to the end condition? I have, up in the while loop, I had to increment this, right? I'm not doing that in the for loop. It's being done for me. Okay, when we start looking at JavaScript, we'll kind of see how that happens. This is kind of like hidden. When you're doing pseudocode, though, I don't want to, some people will show, you'll see pseudocode with like a for loop written in a much more complex way. I don't want to do that to confuse things right now. But we'll see how that actually gets incremented each time it goes around. That will be a little bit more explicit when we do look at JavaScript. But just know that that's kind of happening in the background. Okay. Absolute value. So what's the absolute value of a number? Does anybody remember from math class? Heard a lot of things. They probably, so I'm guessing you all said the absolute value number is the positive version of that number. So the absolute value of 5 is 5. The absolute value of -2 is 2. Okay? So generally, the absolute value of double bar is kind of the way you write that in math class. Absolute value of 5 is 5. Absolute value of -2 is 2. Just the positive version. So I want to write a little chunk of code that takes a variable x and prints out its absolute value. Okay? So how do we think about this? We kind of have two different situations, don't we? If I give you a number x and you don't get to know what that number is, there's kind of two situations that might happen, right? Actually, three. What's one case? It's greater than 0. What's the other case? It's less than 0. What's the third case? It is 0. Yeah. So let's look at doing this. So I just named 3 different cases that I'm going to do different things in those situations. And actually, we can narrow this down to 2, but let's start off with 3. Let's say, if my number is positive, then what am I going to print? I want to print out the absolute value of that number. If it's positive, it's just the same. Any positive number is its own absolute value, right? Like the absolute value of 5 was just 5. That's the same for any positive number. Else, if x is less than 0, if x is negative, is the absolute value of a negative number? Well, it's like it's opposite, right? How do we get the opposite of a negative number? You can multiply by -1, or more easily, just take the negative again. Right? So a little comment just to illustrate that minus minus 2 is 2. Right? Else, it's neither positive nor negative. It's 0. They print 0. I could also just say print x because I know x is the same as 0. Right? Do we understand this logic breakdown? Breaking it down into the different cases and then dealing with each of those individually. Can anybody see a way I can simplify this into just an if-else? So there's different ways, but generally probably the most straightforward is to go up here and do that. And then I don't need this. You can say if x is greater than or equal to 0, print x, because the absolute value of 0 is still 0, right? So that covers that case as well. It kind of folds it into the same. So if x is greater than or equal to 0, print x. Otherwise, print minus x. Cool. Any questions about that? I'm going to do one more, but my laptop's going to die, so give me 2 seconds to go get a power cord. All right. So one more example, and then we're going to kind of break apart and work. And while we're working on the next kind of group or individual problem, you guys can pair up if you want to. Use it as your break to get a drink of water, use the restroom, get a breath of fresh air, etc. So we're going to skip the max of 2 values, 1, and we're just going to do how many quarters. So we're going to say I have a variable called change. Be some amount, could be over $1, could be $1.50, could be 7 cents, could be whatever. It's an amount of money. The most number of quarters I can make using that amount. So for example, if I say if my value variable change is 77 cents, what should I print out? 3. My change is 15 cents? 0. Cool. All right, so how are we going to approach this? What might I need to do? What do you, when you were spitting out those answers, when I said 77 cents and you said 3, what were you doing in your brain to get that answer? You were dividing, right? So another way to do this, so here's the problem with dividing. So if I say divide 77 by 25, I get 3 point something, right? I get 3.08. Put that out. I can't have 0.08 of a quarter, right? I could round potentially, but then that could get me into trouble too, because what if I have, say, 99? 3.96. If I try to round that, I'm going to get 4. I can't get 4 quarters out of 99 cents. Right? So just dividing and rounding, that might be your first instinct. You change divided by 25, and then to say round that number. That might be your first instinct. That's not going to be right. Also, we don't really know how to round, right? This is just something I made up. There's actually another way to approach this. We know that change is greater than or equal to 25. I know what? I can at least get 1/4 out of it, right? So let me keep track of the quarters I've got. I'll say number of quarters. I'm going to start at 0, and I'm going to see how many I can pull out one at a time. All right. So if change is greater than or equal to 25, I know I can pull out at least one. So I'm going to say number of quarters equals paste equals 1, right? That doesn't get me very far, right? Because I have to do this again and again and again and again and again and again and again. So what should I be doing? I should be doing a loop, right? If I start thinking of I have to do this again and again and again and again and again, your brain should go straight to a loop. So rather than using like an if-else, let's say while change is greater than or equal to 25, number of quarters. Do I want to set it equal to 1 now? What do I want to do instead of that? Add 1. Okay, and that's it. That will then print number of quarters. So let's go through this with 77 and see what happens. Okay. So change 77. First loop, I have 77 greater than or equal to 25. That's true. So number of quarters gets set to 1. There's one critical piece I forgot to do there. Does anybody see it? I need to subtract, right? So I need to say change equals change minus 25. What happened? What was going to happen there if I didn't put that in there? Infinite loop. Remember how I said earlier, if you're doing a while loop and you don't update that condition that you're checking, if that variable you're checking each time doesn't get updated, you'll never stop that loop. So change 25. So change equals, if I subtract 25 from 77, I get 52. So I'm going to go around again, second loop. The test is 52 greater than or equal to 25. That's true. So number of quarters gets incremented, that gets set to 2, and change gets decreased by 25. And we go around again, third loop. 27 greater than or equal to 25 is true. So I add 1 more quarter, and then I subtract 25 again. Time around I check is 2 greater than or equal to 25. It's not, so I stop. At the end of the loop, number of quarters is equal to 3. That's pretty cool, right? So we just took this problem that, like, to us as humans, like, was kind of quick to think about and to do, and broke it down into something that a really stupid machine can do on its own. All right. So that's what you're going to be doing again and again and again as you code, is to think this way, to think about what does it actually mean to try to take quarters out of some amount of change, and how can I write this as a recipe with very, very simple rules. Okay, so the next exercise is to write code that write an algorithm in pseudocode that prints the smallest number of coins needed to give back any amount of change. So that means you want to include quarters, dimes, nickels, and pennies. Okay. You also, I said smallest number of coins, right? So if I give you $1.25, what should you give me back? It should be 1 coin, right? Because you can give me a $1 bill. So you want to consider dollars. Don't try to do this all at once. Maybe just do the first piece. Maybe just try to do don't think about the dollar part. Just assume that everything's less than $1 to start off with, and write your algorithm then. Then go back and think about how you might handle that situation when you have more than $1. Okay, so you can work with your neighbor. You can pair up 2 or 3 people at a time. You work on your own if that's how you like it. We have mentors here today that are going to help and walk around while we're working on this. Can you guys raise your hands, gentlemen and ladies? We got a couple back here, a couple over here, one back there. So they're going to be walking around. They're going to be checking in with you, and if you have questions, just like look for one of them, raise your hand. They'll come over and find you and help you work through this. So we're going to spend maybe 10 or 15 minutes, depending on how people progress on this exercise. All right, and again, use this time as a break to use the restroom and so forth as well. How are you doing, folks? If you're not finished, that's okay. If you want a couple more minutes, I can give them to. Anyone want just a couple more minutes? All right, well, let's go ahead, and if you didn't finish, that's fine. This is kind of a more difficult example than we've done so far, so that's okay. I just want to run through it, and there are, again, multiple solutions to this. So if yours is slightly different, that doesn't mean it's wrong. Can somebody hit the main lights in the back, one of the mentors? Okay, so just to restate our problem, we wanted to write an algorithm that prints the smallest number of coins needed to give back some amount of change. Not forgetting that could be more than $1. So let's take my own advice and say that we are not going to worry about the situation where it's more than $1 yet. Let's just assume it's less than $1. So what is maybe the first thing I can do? Well, first, before that, what's our strategy? Before we start like trying to write code here, what's the strategy? If we can't say that in a sentence or two, we probably shouldn't start writing even pseudocode. So that's what I want to do, but the how, the strategy is the how. How do I do that? So we saw how to do that for quarters, right? That will give us the number of quarters in a given amount of change, that little loop up there that we already have. So we're gonna start to start with. We're gonna assume that we'll deal with over 100 in a minute, but let's assume that right now. Let's just assume that like that's not an issue, that we've got less than $1. What should my strategy be? I can find the number of quarters I need. This thing up there tells you the minimum number of quarters to give back, right? That you can give back within a given amount of change. If I apply that to then say dimes and nickels, I can do the same thing, right? So I've got quarters, dimes, nickels, pennies, 4 different types of coins. I can write the same kind of loop for 4 different currency amounts. And I can have like a number of quarters, I can have number of dimes, number of nickels, number of pennies. But I should do those in a certain order, shouldn't I? If I'm going to try to figure out the least number of coins, I first should figure out how many quarters I can get out of there, right? If I have 77 cents and I start by trying to figure out how many pennies I can get out, I'm going to end up with 77 pennies. That's not the least number of coins, right? So this is what's called a greedy algorithm. You're trying to find the most of something, the most number of quarters you can get, then the most number of dimes. So I'm going to start by just doing exactly what I did up here. That's the first thing I'm going to do, is figure how many quarters I can get out of that. I don't need to print anything yet. So now I know the number of quarters. By running this code, I will get the most number of quarters that I can get out of that change. Okay, and I'll be left with something else. Each time I take off 1 quarter, and so I'm left with something else. What do I know about that thing at the end? Once I run that loop, how much change do I have left? It's less than 25, right? Because if it was more than 25, I would have done the loop again. So once I get kicked out of the loop, I know my change is less than 25. Okay? So now change is less than 25. Get as many dimes as possible. So let's comment up here. Let's get as many quarters as possible. Okay, so how am I going to get as many dimes as possible? Right, so the same algorithm, the same principle applies. I just have a different kind of denomination to my currency here. create one called number of dimes. Instead of checking to see if it's less than or equal to 20 or greater than or equal to 25, I'm going to check 10 because I wanted my loop should check, is there enough for at least one more dime? That's what I'm checking each time I go around that loop. Okay, so now this loop will calculate the most number of dimes I can get out of my change after I've already taken all the most number of quarters. Okay? You following it so far? All right. Now, no trick here. What's next? 10, get as many. So we're just going to keep doing this. All right, and finally, I could do this for pennies. What's an even easier way? Now change is less than 5. How many pennies do I have? How many pennies am I going to need? At most 4. Whatever change is left, right? So you could create a number of pennies variable. It's going to be equal to whatever you have left because it's less than 4, and that number is the number of pennies. Okay? So the total number of coins that I've calculated now, I've calculated the most number of quarters, then the most number of dimes, then the most number of nickels, and then the pennies that were left over. I have total coins, a new variable called total coins, and that should just be just each of those, right? Number of quarters. Plus number of pennies. Okay, cool. Any questions so far about how we approach this? Again, there's some slightly different ways to do it, so don't worry if it doesn't look exactly like this. Is that okay? No questions is sometimes good, sometimes bad. I'll make sure we're okay. All right. You're all ready to be cashiers. So one last piece, how do we deal with dollars? I said right now, let's just do this and forget about the dollar thing. So this question kind of depends on like what number we're given. So let's assume that like change is number of total cents, right? So that means that like 177 is actually going to be 177 cents. So let's just make, I mean, we can, this is part of if this was actually in a program, we would have to figure out how to make that happen or tell the user to enter that or whatever. But let's just assume that that's what we're starting with, that the change is the total number of cents. So if I run this now, what's going to happen with, if I ran it with 177 cents, what would happen with the 100 piece of that, the dollar piece of that? I get 4 more quarters, right? But I don't want those. I know I can give back a dollar bill instead of quarters. I'm only concerned about coins. So what can I do to just get rid of a couple different ways I can do this that we've seen in class today? How can I just get rid of the 100 part? There's two explicit ways we've seen in class. Change equals change modulo 100. That's a great one. That's my favorite one because it's short. Remember, modulo takes the remainder after dividing. So 177 divided by 100 is 1 with 77 left over. That's one way to do it. Another way to do it would be to do a while loop like this and just like not count the dollars, to just like let them float away. So that's one, so here's one way. Another way would be to do, say, while change less greater than equal 100, change equals change minus 100. kind of the same as these loops down here. We're just not keeping track of the number of dollars. We're just letting those numbers fly away. So either of those is valid. One's a little bit nicer and cleaner. And that would be the first one, but neither is wrong. Cool. Any questions? How are we feeling? We're about to do some real code. This has been all pseudo fake code, I think. I think that's my next slide. Cool. So let's see what time it is. 3:08. I'm going to introduce you. Here's kind of the approach we're taking right now is we've done all this stuff in pseudocode, and we've done it in a way that we can now kind of easily translate all these things we've been doing into an actual programming language. We're just going to have to be a little bit more careful about how we write things down. So I want to introduce a few kind of basic, I want to translate a few pieces of pseudocode into JavaScript. And then your homework for next week is going to include, and we'll walk through exactly what that is going to include you doing a little bit of JavaScript, but it's going to be pretty simple. So even though we're not spending a lot of time on JavaScript right now, you're going to be able to do the stuff in the homework without you know, undue anxiety. Next week, we're going to like hit JavaScript really hard. So now I just want to give you a taste just so you can connect these two in your brain. So we're not going a week between pseudocode and JavaScript. You can see the parallels kind of right now and start thinking about those parallels. So JavaScript, the first thing about JavaScript I want to say is that JavaScript is a programming language. We've made a distinction between pseudocode and programming languages. And I've said that pseudocode is kind of like English. There's no like specific rules. You can write things like in words and other things that are a little bit easier to understand to a human. JavaScript is a programming language, and that means it has syntax. Syntax is just a fancy word for saying the rules that you have to follow, okay? Syntax is, you know, if you've had like a English degree or something, you know, syntax is distinct from semantics. Syntax is the mechanics of language. It means the exact same thing in the context of a programming language. So when we talk about syntax, we mean the formality of how you write it, not the meaning, not what your code is trying to do, but the actual mechanics and symbols and reserved words and all those things that make the language work. So if you hear me say something like your code has a syntax error, that doesn't mean you're doing the wrong thing. It means you're using the wrong symbol somewhere, or you spelled the wrong keyword. You spelled for with 2 R's or something that the computer doesn't know how to understand. It's a formality. So syntax is the formal rules that we have to use. So I just want to show you a few examples of how things look in JavaScript. So we started out by doing variables today in pseudocode, okay? In JavaScript, to make a variable, do this. I put the word var in front of it. And this tells the computer, hey, the thing that comes after this is a new variable. Okay? And then I set it equal to something, and I put a semicolon. So 2 new things here for us that are different from pseudocode. The word var, which says I'm making a new variable, and then the semicolon at the end. Okay? Semicolon says this is the end of a line of code. We have to tell the computer that we're ending a line of code, so we put a semicolon there. Now, if you've done JavaScript before, or you go home and read about JavaScript, you're going to hear people tell you that you don't have to put the semicolon there in JavaScript, and that's not true. But for this class, we're always going to put the semicolon there, okay? Because other programming languages will make you do it, so it's just a good habit to get into. Once I've created a variable, I don't have to use var in front of it. I'm not creating anymore. It already exists. You can just use it. I can say number of quarters equals number of quarters plus 1. I can do things like that. I can do math with it, whatever. I don't have to use the word var in front of it because I've already created it. Var is only necessary the first time you create it. Another caveat, just like the semicolon, you're going to read things out there on the internet that say you don't have to use the word var. Those people are not incorrect. They're just not very smart. So you don't have to do it. It's just a really bad idea for reasons that I can't really go into with the knowledge we have now. Maybe at the end of the class, we'll have enough to explain why using var or why not using var is a really bad idea. But again, other programming languages, you will have to do similar things. So get in the habit. And there are other, aside from, the semicolon thing actually is pretty optional. The var thing can actually really mess up your programs if you really don't know what you're doing. So go ahead and get in that habit. I can make a Boolean variable. Again, only difference between what we did before, it's actually a weekend, Saturday. The only difference there between that and what we did in pseudocode is the word var and then the semicolon. In JavaScript, false is a special word. It means the Boolean false. And then I can do things like so far it looks pretty similar, right? Not much we're doing differently. Variables are going to be essentially the same. To make a string, and mechanics, just var with the semicolon. So variables are going to be pretty straightforward for us. Just remember, though, as opposed to pseudocode, you need to create your variables before you use them. So before you use a variable, create it. I can make a variable without setting any value to it. So I can say var, launch code wrong, I did. Make a variable without giving it a value. That's sometimes okay. Sometimes can be messy for you. It's legal though. Sometimes you will want to do that, just to say you don't always have to give it a value. But generally, those are the mechanics of variables. And remember, each one of these variables has a data type, right? The first group, those are numbers. Second group are Booleans. Down here, launch code address is a string. So loops, we still have the same two types of loops. I'm going to start with while loops because those are simpler. And I'm going to do a loop similar to what we did in our example before. Let me give some more room down here so I can move this up the screen. Okay. So I want to loop and print out every number between 1 and 100. The first thing I'm going to do is to create a new variable like we did before, number to print, set that equal to 1. While prints is less than or equal to 100. Print it out. I need to increase it by 1. Okay, so let's break this down. That was pretty quick. I just dumped a bunch of new stuff on you. So, but at the end of the day, you're going to see this is not that different from the previous while loop. So I can run up and find it here. Here's the pseudocode version, which we understood. We just had, we didn't have to make our we didn't have to use vars. We didn't have any parentheses or braces. We just used the word print to say, hey, I don't know what that means, but print, sure, go do it. Now we're in a programming language. We have to be a little bit more specific about stuff. We have to create our variables. This is called variable declaration. When we use a loop, we have to put our check, our condition, inside of parentheses. We have to do that. And then the stuff that's inside the loop, we put inside braces. And the reason we put it inside, those are curly braces. Those are on the keyboard. Those are up by the P key next to your square brackets. Those just say to the computer, everything between these two braces goes with the while loop. So if I did this, that would be a very different result. That would say this line down here doesn't get repeated as part of the loop, which means what about my loop now? What bad news is going to happen? It's never going to stop, and it's going to print out the number 1 forever. So you need to be careful about what you. This is actually a good thing. It makes it easier to read it. It says very explicitly, the stuff between these braces is what gets repeated. And this says the stuff between these parentheses is what you're checking each time you go around. Okay. Console, thank you. I was going to unintentionally skip over that. That is how we print in JavaScript. So don't worry about it too much right now, other than know that is the way you print something. We'll learn a little bit more about where it's printing and how it's doing that, probably in future classes. But that's just that's what it is. It's an example of a function. We're going to learn about functions next week. It's a function that takes the thing you want it to print, and then it goes out and figures out how to actually do the printing, because we don't know how to do that. So good question. Don't worry about it too much. Just know that that's what it does. So let's do the same thing with a for loop. So here, this one is gonna, sorry, it's not gonna be fun. For loop is better, in some ways it's a lot worse. So let's look at what we just did. The better part is that what's inside the loop, what's inside the curly braces, is a lot shorter, right? There's all this kind of bookkeeping that I was doing before that's just like that's not inside the loop anymore. The bad part is this line is really nasty and is kind of confusing. So I'm going to write just a kind of more abstract version of what a for loop is to kind of break this down. That's kind of what a for loop generically, the structure of it is in a generic way. Inside of my parentheses, I've got three statements that are separated with a semicolon in between them, right? So on the left, I've got var number to print equals 1, semicolon. That's one statement. Number to print less than or equal to 100, semicolon. That's another statement. Number to print plus plus, that's another statement. So I've got three things. Each of those three things is serving a different purpose in the context of the loop. The first one is creating my loop counter. Okay? So like in the while loop where I created my loop counter above before I first started, now I'm just kind of folding that into the syntax for a for loop. That just happens within the parentheses for my for loop. So I create the loop counter. When you see for loops, you'll often see I as the loop counter used, but we can make it whatever we want. The second statement, number to print less than or equal to 100, that's our condition, that's our test. That's what we test each time we go around to determine whether or not we keep going. Just like in a while loop, we had that condition inside the parentheses. So it's serving the exact same role as that conditional test in the while loop. And then the last piece is the update. What do I do at the end of each loop iteration before I go back and do it again? Plus plus is another new thing. It just means add one. It's just shorthand. It says add one to this thing. So it's the exact same as line 159. Just a lot shorter way to do it. So this is really confusing. It's going to take you a while to get used to this, which is why I'm going to introduce it once and again and again and again. We'll talk about it again in detail. We'll do this exact same deep kind of detailed description of for loops, but that's what's happening. At some point, you'll kind of just get used to it. You'll get used to how to build for loops and how to get used to the syntax, and you'll look at it and it'll make sense. You'll be like, oh, that for loop runs 117 times. I got it. You'll be able to do that. Right now, this just looks like gibberish. So I'm sorry, but that's the way it works. We'll get used to it. We'll get through it together. The nice thing about it, though, is there's a lot of work that's being done for us. By putting these statements here, there's a lot of bookkeeping work that's being done. It makes it less likely that I'm going to screw something up because I don't have to do that. I don't have to remember exactly how to update my loop counter. It's being done for me. Okay, so that's a for loop. Any questions? I know that one was really confusing. Yes. By itself? Readability. So you don't have to do it. I could put it like here. All this stuff in the same line. The reason I don't is that it just makes it really hard to read. So again, this is one of those conventions that we use to make things nice. Mm-hmm. Yeah, so this is just like do something. It's like where the code would be. This is not an actual loop, so I put it as a comment because if this was actual code, it would break. It doesn't like, first value, test condition isn't, it's just English. This is like pseudocode more than, so I put it inside of a comment to say that this is a note. It's not actual code. Yeah. That, I don't know if you can legally do that. No. You know what? You can put them on separate lines. The reason we don't, again, is more or less kind of convention. You'll never see people do that. I think it is actually legal in terms of the syntax of the language. Like the computer will let you do that. But usually it's just a lot more compact. So most of the times you'll see for loops like this. So I could, this, once you get used to reading for loops, you'll just look at that and know exactly what it's doing. But, there's not as much, you could do some stuff like this. It'd be a little bit overkill, and it'll actually will be less readable once you're used to the way it looks. That's not a great answer. I'm sorry. Okay. Yeah, so it's legal, but you'll never see that happen, really. I'll never say never, but okay, so conditionals. So conditionals are, for loops were hard in terms of going to JavaScript. Conditionals in JavaScript are going to be nicer because they're pretty similar to what we did in pseudocode. So I can say if, let's find a condition that we used before. This one. Let's translate absolute value into pseudocode. Okay. If x is greater than or equal to 0, notice I have a condition, so I'm putting that in parentheses. Positive, that means its absolute value is the same as x. Else, if the value is the opposite of x, it's minus x. So remember, console log just means print. So this is similar to before. The conditions go inside of a parentheses. The actual stuff that goes with that, this parentheses, or this bracket block means that console.log goes with the if. This means this console.log goes with the else. So you could also write them like this, and this might be like more understandable for you to start with, more readable. This just means this stuff between these two brackets goes with the if. The stuff between these two brackets goes with the else. And you can also do else ifs and all that sort of stuff in the same kind of way. Cool. So that's just very brief. We're going to do this again and again and again. So if that didn't sink in the first time, totally, don't worry. Just I wanted you to see some JavaScript. And now that you've seen a little bit of it and know that there's this kind of this parallel between the pseudocode we've been doing and JavaScript, you're going to do some basic JavaScript stuff over the next week, and you'll be able to kind of make those connections and work through stuff. So in the 5 minutes we have left, I want to talk about the homework a little bit. And then also myself and some of the mentors are going to just stay around for a while. So if you have more questions, you want to start working on stuff, whatever, you can feel free to stay essentially until 5 o'clock if you want to. And don't forget Mondays from 5:30 to 7:30, we're here as well. So let's see. Where's the homework? On the calendar. So we've got some pseudocode stuff. So these are some pseudocode things. I mean, in terms of difficulty, these are going to be kind of on par with the stuff we've been going through in class. This last one is kind of more challenging just because it uses something called the Fibonacci sequence, which is, if you've never seen before, is going to be really confusing. That said, we used this in the last class, and I do think it's a cool problem. So I put challenge problem on that to say, if you get there and you look at the Fibonacci sequence, you've never heard of the Fibonacci sequence before, and you look at it and you're like, this makes no sense to me, this is crazy, just don't worry about it, skip it. But if you have seen the Fibonacci sequence before, go ahead and try to do that one. And then getting started with JavaScript. So here, what we're going to do is we're going to use an online resource called Codecademy, and the link is in the problem set. So the first thing to do is to go create an account. They have paid accounts, but we're not going to need anything that you need to pay for. We're just going to use the free stuff. So you'll create an account, and I already have one. All right, so once you're in, the link to what we're going to be doing is over here as well. It's the JavaScript class. You can kind of find it just by poking around, but I gave you the link to the JavaScript class. And there's a bunch of different units, and within those units, there are different lessons. And so we're going to do, over the next 2 or 3 weeks, most of the stuff in here. These things that have lock symbols on them just means that's stuff you got to pay for. We're not going to do that. But to get started, Unit 1, Lesson 1, you just click on it. And I've been in here poking around, so it'll actually land you on the first one. And the way this works is you're given an assignment on the left. Here's your exercise. Right here is a place for you to write code. When you want to run that code, you hit save and submit. That will check it, actually run it, spit out the results over here in this little black box, and then tell you whether or not you're right. So let's just do one or two together, okay? So let's see, this says, write your name within quotes like this. What is that doing? It's a string, okay? So I just have a string. There's no variable, just a string. Cool, I did it right. If I didn't do it right, if I say I forgot the second quote, it's gonna tell me this. It says, oops. So there's two things I get here. I get an error message at the bottom, which is it telling me that I failed. And actually and so there's two things here. This one is like, Codecademy is really helpful. It tells you exactly what you did wrong sometimes. Here is what you would see in like the real world. That's the real error message that a computer would spit out at you. It says syntax error, unexpected EOF. That's like a lot of error messages you'll see, just like not humanly intelligible, but there are some clues there. Syntax error. What did I say about syntax? What is syntax? It's the rules about the programming language. So it means that something I did broke the rules of the programming language. In this case, there's not a lot of code to look at. I can probably look at it and be like, oh, yeah, duh, I don't have a closing double quote, right? So that's the easy way to fix it. So then you just go to the next lesson, and you can go ahead and, I've already done these, so that's why that code's there. You'll just get a blank editor. So go through these. These are pretty self-guided. The error messages are very helpful, so I think you'll be able to get through a bunch of these, if not all of them on your own. And if you do get stuck on stuff, Piazza's there. Go ahead and post messages or questions on Piazza and work through these and try to get some JavaScript under your belt before next week. And so I tell you to go through, I forget, there's some number of these I tell you to go through up through exercise 11 in that first unit. Cool. Any questions about homework and what to do? Again, Monday night, 5:30 to 7:30. Come hang out if you can. And then otherwise, we'll see you next Saturday. Thanks, everybody. And again, feel free to hang on for a while as long as you want to today to work or ask questions about stuff.